So we're now going to turn our attention to common Java streams factory methods. So if you recall, we had talked briefly about what factory methods were earlier, and now we're going to go into more detail about some of the more common ones. There's several ways, several common ways, to obtain a stream from various types of input. One very common way is to get it from a Java collection. So here you can see we use the of factory method in order to be able to take this array of names and create a list of them. And once we have that list, then we go ahead and we can use the stream factory method. So that's one way to do it, and that creates a sequential stream. And that's the approach that we're using here in our simple search stream program. Or we could also use ParallelStream. And ParallelStream will create a parallel stream, and we'll talk more about that. We gave a quick overview earlier, but we'll go into that in more detail. So those are by far the most common ways of doing things. Another interesting variant that we can also apply is where we can have a sequential stream created first, and then while we're doing the chain of fluent operations flowing down from that stream, we can put in the .parallel operation. And that basically tells the stream, run this thing as a parallel stream even though it was initially created as a sequential stream. And this guy has some subtleties associated with it, the most important of which is it doesn't matter where this thing appears as long as it comes after .stream. That is what the stream will be at that point. It'll be parallel. Just to be confusing, there's also another operation called .sequential that does the reverse operation. So if you created something as a parallel stream and then decided to make it sequential for whatever reason I can't imagine, then you could switch off the parallel feature. And whichever one of these things occurs last, either parallel or sequential, that's the one that wins. And so then the whole stream is processed by whatever comes there. This may not be clear why this is a useful feature, but I'll show you some really cool things later as to why it's cool. The reason why it's cool is you can dynamically decide whether to make a stream sequential or parallel, which can often be useful for either testing or for certain kinds of optimizations you might want to apply under certain conditions. Another way to create a stream is from an array. So here we have an array of strings, and you can see that we can use the Arrays utility class and its stream factory method to convert the array into a stream. And then once we have a stream, we can then go ahead and print the contents of the stream. So here we can use the for each method, which is a stream method, and we can either use a lambda expression or we can use a method reference to print the contents of that array out. So that's one way to do things. Another way to do this is to use a static factory method on stream, which is the Stream.of method. And I kind of like this one a little bit better than the Arrays.stream, just because it's kind of more consolidated with the streams abstraction. So in this case, we have, again, an array of strings. We can convert that to a stream of strings, and then we can apply the for each method on stream in order to be able to print them out as either a lambda expression or using a method reference. There are yet other ways to create streams that use static factory methods, and this is a particularly interesting one. This is the iterate factory method. And what this method does is it is given a seed, and then it's given a method to run. And then it goes ahead and applies this thing over and over and over again to do transformations based on the initial seed. This particular program, as we'll see in a second, generates and prints the first 100 Fibonacci numbers, which is kind of a cool program to see how this works. It's really interesting. I don't know if I would necessarily write it like this, but it's kind of fun to see how it works. So this parameter that we pass to iterate is the first parameter is the seed, which defines the initial element that seeds the stream. So in this case, we're going to create an array of big integers that has two elements, and they both initially have the value 1. So item 0 has 1. Item 1 has 1 in that two-element big integer array. And then we define a lambda function, which is applied to the previous element to produce a new element. So what this is going to do is it's going to say, make me a new big integer that takes f. F is what happened before, starting in the initial case with this two-element array containing 1s. It says, take the first element in f, which is the array, and use that as the first value of this new two-element big integer array, and then take the 0th element and add it to the first element to create a new element. And if you think about it, that's the recursive definition of the Fibonacci sequence. So f of 1 will be the first element in this new big integer. F of 0 plus f of 1 will be the second element in this 2-element big integer array. And then that'll take place forever, right? This will generate forever, except we don't want to go forever. So what we're going to do is we're then going to go ahead and apply the map intermediate operation that takes that 2-element array and just takes the 0th item. So this is going to take the infinite number of 2-element arrays that are generating the Fibonacci sequence ad infinitum, just strip out the first element, and then we're going to go ahead and limit ourselves to the first 100. That's a good example, by the way, of a short circuit operation. So this short circuit operation says stop after 100 of these things have been seen. And then, oh, by the way, the final thing we do here is we go ahead and we're going to use the for each terminal operation. That, of course, will start the whole stream because terminal operations cause the lazy stream to become active. And we're going to use the system.out : println method reference to print the first 100 Fibonacci numbers. So a rather unique and somewhat eclectic way of printing the first 100 Fibonacci numbers, but I think it's kind of a cool way to show how streams work. One thing to be aware of is avoid using iterate and parallel and limit, perhaps, together. Iterate and parallel and limit don't play together very well. And it's kind of overkill in this case to do this in parallel. You're probably going to get very slow performance. This is actually a good example where it's likely that a parallel stream will be very, very slow relative to a sequential stream trying to do this. And that's because there's all kinds of coordination that has to be performed in order to obey the semantics of streams when used in this fashion. So it works, but it's not a good thing to do. OK, so that's an overview of some of the common stream factory methods. And actually, to be honest, stream and parallel stream are very, very common. The Stream.of method is not uncommon. The Arrays.stream method is not uncommon. The iterate method is kind of uncommon, but I just had too much fun putting it in there to spoil it by moving it to the next discussion.